So today I am going to talk about the physical meaning of gradient of a scalar field, right? So as we have discussed in the earlier lectures that scalar fields are represented by level surfaces. Scalar fields are represented by level surfaces, right? What does it mean? Say if we are having two surfaces, this is one surface, this is another surface, then for this surface S1 and for this surface S2, it has some constant value of the scalar function or the scalar field. Say it is phi 1, and for it is phi plus delta phi. So these both have the same value, right, which we have to keep in mind. So these are known as level surfaces. So keeping this thing in mind, we have considered two level surfaces. Surfaces S1 and S2 having value of scalar field phi and phi plus d phi, right? Now consider 2 points on the surface A and B. So this is a point A which we have considered over this surface, and there is another point which is B which I have considered here over this surface, and say its position vector is represented by r vector and its position vector is represented by r plus delta r vector or r plus dr vector. So this vector is basically the displacement vector, right? So I have chosen 2 points on surface, 2 points A and B on S1 and S2 such that this OA vector is equal to R vector and OB vector is equal to R plus dr vector, and AB is equal to dr vector. Now if we draw a normal to the surface S1, say if I am drawing a normal to this vector, say this is the normal vector which I am drawing, it's along this way, and let me call it as dn vector, and this dn vector what I did, now I draw normal to the surface S1, normal to the surface S1 at point A. Now what is the property of a normal? Normal between two the surfaces, normal between two surfaces shows the smallest distance between them, right? And let this distance will be AC. AC, and this is represented by dn vector. And let me rewrite down dn vector. Dn vector is the magnitude of this vector multiplied by its direction, and let me call this direction as n cap. This along this way, right? This is n cap direction. But if it makes an angle theta with dr vector, so that means this is dn vector and this is dr vector, and this is the smallest distance. So that means dn vector, its magnitude in terms of dr can be written as, say if it is an angle theta, then I can write down that dn magnitude is equal to dr cos of theta, and it is directed along n cap. So therefore I can write it down as dr cos of theta n cap, and this is nothing but this is like a dot product. Sorry. So it can also be written as, if I recall the definition of dot product, then it can be written as dr vector dot n cap, right? Now change in phi with respect to change in r, it represents the rate of increase of phi at a in the direction of AB, in the direction of AB, but looking at this so if delta r becomes minimum, what does it mean? That means delta n minimum means dr will be minimum if it is along delta n, right? That is delta r is along delta n. In that case this dr will be minimum. Or if I put this in this, then this will become means if I try to look at it, means delta n over delta r, and if will become minimum, this makes this quantity as maximum because denominator will become minimum. Due to this, d phi becomes maximum. This we have to keep in mind. So therefore what I can write down, this is a very important point. So therefore this d phi can be written as delta phi over delta n into dn vector. It can be written this way. Or this is equal to delta phi over delta n cap dr vector. Right? So this is the equation number 1. And if I recall the definition of differential, then according to that this can be written as curly phi over curly x dx, curly phi over curly y dy, curly phi over curly z dz. This is the definition of a differential of some function. So let me rearrange it. It is dx I cap dy j cap dz k cap into curly phi over curly x I cap, curly phi over curly y j cap plus curly phi over curly z k cap. And this is nothing but it is the dr vector and gradient of phi. This is the definition of gradient, if I recall that. So therefore this can be written as gradient of phi dot dr vector, and this is the equation number 2. If I compare these two equations, then what we are getting is I have to equate these two equations. So that means gradient means del dot phi dr vector. This is the equation number 2. And if I equate these two equations, then what we are getting, this is del dot phi dr vector is equal to change in phi over change in n cap dr vector. And if I compare these two, then this will cancel out in a way. So therefore this del dot phi is equal to delta phi over delta n cap. This is basically gradient of phi. Thus gradient of a, so this represents change in phi with respect to in which the phi changes, change in phi will be maximum, as I stated earlier. So thus gradient of scalar field phi is a vector whose magnitude at any point is equal to maximum rate of increase of phi and directed along the direction in which this maximum change occur, that is perpendicular to level surface at that point, So this is the physical significance of this gradient of a scalar field. So that's all for this lecture, and in the next lecture I will talk about some problems relating to gradient of a scalar field.